Hello students, welcome back. Today we'll continue with exercise 1.3. In our last video lecture, we had completed till question number 5. So today we'll start with question number 6 and complete this exercise. Okay, so let's begin with question number 6. Okay, show that the domain is from -1 to 1 in closed interval bracket to R, given by fx equal to x plus 2. F of x is equal to x upon x plus 2 is 1 1. You have to show that it is 1 1. Find inverse of the function. Okay, if it is onto, then its inverse is possible. And here for inverse of the function, it's -1 of 1 to range of f. Okay, so let's see first it is 1 1 or not. Okay, for 1 1, let f of x1 equal to f of x2. So that means x1 upon x1 plus 2 equal to x2 upon x2 plus 2. Cross multiply x1 into x2 plus 2x1. This one x1 into x2 plus 2x2. x1 x2 x1 x2 gets cancelled. That means 2x1 equal to 2x2. That means x1 equal to x2. Okay, hence it is 1 1 function. Okay, clear? Okay, now you have to find out the inverse of the function f minus 1 to 1 in closed interval bracket to range of f. Here it's clearly given range of f, that means definitely it will be onto function. Okay, so for inverse, let f of x equal to y. We will take f of x equal to y. That means x upon x plus 2 equal to y. So that means x equal to xy plus 2y. Okay. So when I will carry it forward here, x minus xy, this will be equal to 2y. X I will take common, 1 minus y equal to 2y. So x is equal to 2y upon 1 minus y, right? So if I have taken fx equal to y, that means x upon x plus 2 equal to y, and then I found out the value of x. Clear? So this will be the inverse. Okay, I can also do it in this way: f of 2y upon 1 minus y. Clear? So what I will get, instead of x, 2y upon 1 minus y upon 2y upon 1 minus y plus 2. I am putting this function x upon x plus 2. Okay, so what I will get here, 2y upon 1 minus y, 1 minus y, it will get cancelled LCM. 2y plus 1 minus y into 2, 2 minus 2y. So 2y, 2y gets cancelled. So 2y by 2, this will be equal to y. Right? Hence, f inverse is f of inverse x. This is the inverse. 2 instead of y, I will put now x upon 1 minus x. This is f inverse. Clear? Okay, so you can do also the similar thing like what we are doing in onto function. Okay, we are using this fx equal to y for onto. The value of x that we get, that will be equal to f inverse and f inverse y, or else if I am taking f inverse x, then just replace this y by x. Clear? So this was about question number 6. Just note it down. Now let's move to the next, that is question number 7. Question number 7, consider f r to r given by fx is equal to 4x plus 3. Okay, f of x, that is equal to 4x plus 3. So f is invertible and find inverse of f. That means I need to prove it is 1 1 and onto. Okay, so for 1 1, let f of x1 equal to f of x2. Okay, so what does that imply? 4x1 plus 3 equal to 4x2 plus 3. Yeah, 3 will get cancelled. So 4x1 will be equal to 4x2 here. So 4 will also get cancelled. What does this show? This shows that x1 is equal to x2. Okay, we started with fx1 equal to fx2 and we proved x1 is equal to x2. Therefore, it is 1 1 function. Okay, now let's prove that it is onto function. It's clearly given that show f is invertible and find the inverse. That means definitely it must be onto. So for that, what we will do, we will take f of x equal to y. So 4x plus 3 equal to y, 4x equal to y minus 3, and x equal to y minus 3 by 4. Okay, so now what I will do, I will take f of x, that is equal to f of what is x, y minus 3 by 4. So 4x plus 3, so it's 4 into y minus 3 by 4 plus 3. 4 gets cancelled. Y minus 3 plus 3, that is equal to y. Okay. So for every y belonging to the codomain, there exists some x belonging to the domain such that f of x is equal to y. Therefore, it is also onto function. Clear? Now you can see here it is 1 1 function and also onto function. Hence, f is invertible. Okay, and f inverse x is equal to, I will use this, but instead of y I will put x because I had taken f inverse x minus 3 by 4. If I take f inverse y, then it will be y minus 3 by 4. Okay, so this is f inverse x. Here, so this was about question number 7. So just note it down. Okay, now let's move to the next, that is question number 8. Consider f r plus, means only positive number you can take in the domain, from the domain, to 4 to infinity. Okay, codomain that start with 4 and then up to 8 infinity, sorry, given by fx is equal to x plus 4. F of x is equal to, sorry, it's x square plus 4. So that f is invertible again. Now you already know that it is invertible because you have to show it, right? So you got a hint that it is 1 1 and onto, and that's what you have to prove. With the inverse, f inverse of f is given by f inverse y is equal to root of y minus 4. Means you have to prove that it is invertible function and f inverse y is equal to square root of y minus 4. Okay, so first let's start for 1 1. Okay, let f of x1 equal to f of x2. That means x1 square plus 4 equal to x2 square plus 4. 4 gets cancelled. X1 square equal to x2 square. So now when I take square root on both the side, we will get plus or minus. Okay, but see the domain, it's r plus. So I cannot take negative value. I can only take positive value. That means x1 will be equal to x2. Hence, it is 1, 1. Okay. Now, so take a note. If it was R, instead of R plus, if it was R, then it would not be onto. Because at that time, x1 can also be equal to minus x2. But here we cannot take negative value from the domain. So x1 is equal to x2. We started with fx1 equal to fx2. And we proved x1 equal to x2. Therefore, it is 1 1 function. Okay, now for onto. Okay, so for onto we will take fx equal to y. What is fx? X square plus 4 equal to y. So x square is equal to y minus 4 and x will be equal to square root of y minus 4. Now see here also it can be plus or minus, right? But range we cannot take any number less than 4, right? We cannot take any number less than 4. So this will be greater than 0, hence square root is possible. Clear? And the domain x cannot be negative. So it will be only plus square root of y minus 4. Clear? So now let's take f of x equal to f of square root of y minus 4. Clear? So what is this? X square plus 4. This will be square plus 4. Square root of y minus 4. So this will be equal to square root and square. It will get cancelled. Y minus 4 plus 4 and this is equal to y. Therefore, for every y belonging to the codomain, that is minus 4 to infinity, there exists x belonging to the domain such that fx is equal to y. Therefore, it is onto function. Okay, clear? And what we got from this? Okay, say first as it is 1 1 and onto, right? I will say it as, hence it is invertible. Okay, I will say hence f is invertible function and f inverse y. I will use this just a minute. I will use this one. Okay, that will be equal to square root of y minus 4. Okay, so this is f inverse y. We had proved that. Clear? So this was about question number 8. Okay, so note it down. Okay, now let's move to the next question. Question number 9. Consider f, the function f as r plus 2 minus 5 to infinity. Okay, now what is fx? 9x square plus 6x minus 5. Okay, again show that f is invertible with f inverse y equal to square root of y plus 6 minus 1 by 3. Again you got the hint. Question says so that f is invertible. That means it will be 1 1 and onto. Clear? Now let's say for 1 1. Remember, if it was f from R to R, then this type of function will never be 1 1 and never be on. If it is R to R, okay. But see here it's R plus, okay. Okay. Now fx I will write down. Let f of x1 will be equal to f of x2. Then 9x1 square plus 6x1 minus 5 equal to 9x2 square plus 6x2 minus 5. So see, minus 5 gets. So 9x1 square minus 9x2 square, 9 common, plus 6x1 minus 6x2, 6 common. I am taking on one side, so it's 9x. This is equal to 0. Now see, x1 square minus x2 square, that is equal to x1 minus x2. I can write down this as x1 minus x2, x1 plus x2. So I can take x1 minus x2 common. Okay. So now see here, this will be equal to, let me write it down here, x1 minus x2 common. So here it will be 9 into x1 plus x2 plus 6. This is equal to 0. Okay. Now see this bracket, plus 6 positive. 9 into x1 plus x2. Now see x1 and x2, that is r plus. You can take any value from r plus. So x1 is positive, x2 is positive, into 9 plus 6. So this bracket cannot be equal to 0. So what does that mean? That means that x1 minus x2 is equal to 0. Why? Because 9 into x1 plus x2 plus 6 is not equal to 0. Okay. In ordinary case, you are writing either first bracket is equal to 0 or second is equal to 0. But here clearly this is not equal to 0. So x1 minus x2 is equal to 0. So what does that mean? x1 is equal to x2. Here we started with fx1 equal to fx2 and we proved x1 equal to x2. Therefore, it is 1 1 function. Clear? Okay. Now let's check for onto. So what we do for onto? Fx is equal to y. So what is fx? 9x square plus 6x minus 5 equal to y. Okay. Now so in such type of equation, okay, when it is one x is having power 2 and one is having 1. So what you have to do, if you want to find out the value of x in terms of y, then try to make it a perfect square. Okay. So what is the formula for last term? Middle term square upon 4 into first term. What is middle term here? 6x. So 6x square. 4 into first term. So 4 into 9x square. X square cancel. Okay. 9 4s are 36x square. Middle term will be 36x square. 6x square, so 36x square. So 9 4s are 36. This will also get cancelled. So it is equal to 1. So now what I will do, I will write it down. 9x square plus 6x, it's minus 5, so I can write it down plus 1 minus 6, that is equal to y, because 1 minus 6, that will be equal to minus 5. Now this is a perfect square. Okay, that will be equal to 3x plus 1 whole square minus 6 equal to y. So 3x plus 1 whole square equal to y plus 6. Here. So now see, as it is a perfect square, 3x plus 1 whole square, taking square root, 3x plus 1, that will be equal to square root of y plus 6. So that implies 3x equal to square root of y plus 6. minus 1, and x will be equal to square root of y plus 6 minus 1 upon 3. Here, so I got it, x equal to square root of y plus 6 minus 1 upon 3, right? So I took fx equal to y and I proved that x is equal to this. So hence it is onto function. Okay, when I will take fx equal to this f of square root of y plus 6 minus 1 by 3. Okay, let's take fx that is equal to f of square root of y plus 6 minus 1 upon 3. Okay, when I will solve this, see what I get. I will get here, it is 9x square, so 9 into square root of y plus 6 minus 1 by 3 whole square plus 6 into square root of y plus 6 minus 1 by 3, okay, minus 5. Here, so this will be equal to 9 into y plus 8 minus b whole square. Okay, below it will be 9. Clear? So a minus b whole square, a square that is y plus 6 minus 2ab, 2 root y plus 6 plus 1. Okay, plus 6 into, so 3 ones are 3 twos are. So 2 root y plus 6 minus 2 minus 5. Here 9 gets cancelled. So this will be equal to y plus 6, or else I can see easily write down here my minus 2 into root y plus 6 plus 2 into root y plus 6. 5 minus 2, that is minus 7, and here 6 plus 1, so that is 7. So answer I got here is y. Okay, so for every y belonging to the codomain, okay, what was codomain here? It was minus 5 to infinity. There exists x belonging to the domain such that f of x equal to y. Therefore, f is onto function. Clear? Hence, f is invertible and f inverse y. This will be equal to, I will take this value, see, square root of y plus 6 minus 1 upon 3. Clear? So this was about question number 9. Okay, now note down question number 9. Now let's start to the next, that is question number 10. Question number 10. F(x) to y be an invertible function so that f has a unique inverse. Okay, now see, we know that if I will take a composite of the function and its inverse, it will be identity function. Like if I take here f f inverse, I will take, if I take y, because inverse I will do, so I need to take from this, then this will be equal to identity function over the codomain of y. Clear? Here the codomain is y, so I can write down y. If the codomain was r, I will write down ir. Clear? So now let's see. Let G1 and G2 be the inverse of f. Means see, I am taking two inverse. You have to show that it is having a unique inverse. So I took two inverse, G1 and G2. Now I will prove that G1 will be equal to G2. That means both are same, and hence we will get that f has a unique inverse. Okay. Now say G1 and G2 are the inverse. We know that f o f inverse equal to identity function. So I can write down here that f o G1 of y, this will be equal to identity function of y. Right? I will write down iy. Also f o G2 of y, this will be also identity. Right? This will be also identity. Clear? Because G2 is also inverse. So from 1 and 2. Okay, from 1 and 2. From 1 and 2, I can write it down FOG1 of y equal to FOG2 of y. So f of G1 of y equal to f of G2 of y. Okay. Now see, f is 1 1 and on 2. How? It is given f is invertible function. That means f is 1 1 function. Now f is 1 1 function means f of x1 equal to f of x2 implies x1 equal to x2. So f of g1y equal to f of g2y. This implies g1y is equal to g2y. So see, that means g1 and g2 are same function. Okay. G1 and G2 are same function. That means the inverse is same. Hence, F has unique inverse. Okay. So that was about question number 10. So just note it down. Now let's move to the next one. Question 11, consider F1, 2, 3 to ABC. So this is the domain and this is the codomain. Given by f of 1 equal to A, f of 2 equal to B and f of 3 equal to C. Find f inverse and show that f of inverse is equal to f. Okay, now say f of 1 equal to A, f of 2 equal to B and f of C, sorry, it's 3 equal to C. Okay, so clearly you can say it is 1 1 because 1 is having different, 2 is having different value, 3 is having different value. So 1 is to 1. Okay, and also all the elements of codomain A, B, C are having the pre-images like 1, 2 and 3. Therefore it is 1, 1 and on 2 and hence it is invertible. So now f of 1 is equal to A, that implies f inverse A, that will be equal to 1. F2 equal to B implies F inverse B, that will be equal to 2. F3 equal to C implies F inverse C equal to 3. So what does this implies? F inverse is from 1, sorry, A, B and C. Right? I had taken the value A, B and C. What is the codomain? That is 1, 2, 3. The range that I got. Clear? This is f inverse. Okay, so this is f inverse. I found it out and such that f inverse A equal to 1, f inverse B equal to 2 and f inverse C equal to 3. Here this is f inverse. Now you have to show f inverse of inverse is f. Clear? So now see, f, again I am writing. What is f inverse A? 1. F inverse B, 2, F inverse C, 3. Now see, 1 is to 1 correspondence. So it is 1 1 function, and for every element of codomain there is the pre-image in the domain. Hence it is 1 1 and onto. That means F inverse is also invertible. So now F inverse A is 1. So inverse of that means F inverse of, I will write down, sorry, F inverse of 1, that will be equal to A, reverse. F inverse of 2, that is equal to B. F inverse of 3, that is equal to C. So I can write down F inverse of inverse is from which elements I taken? The domain 1, 2, 3, 2. What I range I got? That I will take it as codomain A, B, C. Now see this function. This is equal to F. Okay, see that trait and this. Here F inverse and F both is same, and this is F inverse from 1 2 3 to ABC. F is from 1 2 3 to ABC. Hence F inverse of inverse is equal to F. Clear? This is our answer. Okay, so note down question number 11. Okay, now let's move ahead. Question number 13, that is MCQ. Okay, f of x, that is given as 3 minus x cube whole raised to 1 by 3. You need to find it out, f of x. Opposite function, so this will be f of x. Okay, now what is fx? Let's put its value, 3 minus x cube whole raised to 1 by 3. Again f, so I will use this function, and at the place of x I will put bracket 3 minus 3 whole raised to 1 upon 3. Now see, here it was x, I had written x. It's 3 minus x cube whole raised to 1 by 3. So 3 minus x cube whole raised to 1 by 3. Okay, so carry it forward here, this will be equal to 3 minus, see here, 3 and 1 by 3, that will get cancelled, so the power remain 1, minus 3 minus x, okay, whole, oh sorry, now it's nothing remaining, 3 has get cancelled, so it's 1 by 3. Okay, so now 3 minus 3, it will get cancelled, minus plus x, so it will be x raised to 1 by 3. Okay, here there is a mistake, it's x cube. Clear? So here it will be 3 minus 3 cancel, minus minus plus x cube whole raised to 1 by 3. So again 3 gets cancelled and the answer is x. So C is the correct answer. I can write it down, f of f, that is identity function. Here, so this was about question number 13. So just note it down. Okay, now let's move to the next. That is question number 14, which is the last for this exercise. Question number 14, f r minus minus 4 by 3 to r be a function defined as fx equal to 4x upon 3x plus 4. Okay, f of x equal to 4x upon 3x plus 4. Okay, the inverse of f is the map G. Range of f to r minus minus 4 by 3 is given me. So you need to find out the inverse. So what I will do, I will take this as y. I will take it as y. So 4x is equal to multiply 3xy plus 4y. So now 4x minus 3xy. This implies 4x minus 3xy is equal to 4y. Now what I can take common? I can take common x. 4 minus 3y, that is equal to 4y. So what does that imply? X is equal to 4y upon 4 minus 3y. That means the inverse, okay, g of y, okay, its inverse g of y will be equal to 4y upon 4 minus 3y. Clear? So it's 4y upon 4 minus 3y. Option B is the correct one. Yeah, this was about question number 14. Just note it down. Okay, so that was about question number 14. Okay, students, so that's it for today. Here we had completed exercise 1.3. In our next video lecture, we will study about binary function. Then we will start with exercise 1.4. Okay, that's it for today. Thank you.